All right, today we're going to tackle a really fascinating puzzle, one that comes from a world that is definitely not our own. We've got just one single piece of data, this one cryptic date, and our job is to figure out what on earth it actually means.
And this is it, 11,520 AQ. Right off the bat, you notice just how big that number is. And then, of course, there's the AQ. What does that even stand for? It's clearly not from any calendar we use here on Earth.
So that's the big question for today, right? How do we take this alien timestamp and translate it into something that makes sense on our own human timeline? Let's see if we can crack this thing together.
Okay, so with any kind of translation puzzle, you need a key, like a Rosetta Stone. So our very first step has to be finding the basic rules of this AQ calendar system. We need to figure out how they measure something as fundamental as a year.
And there we go, our first huge breakthrough. AQ stands for Arreqqana year. And here's the most important part. We know its length. It's 480 Earth days long. And they've broken it down into 15 months, each with 32 days. I mean, that's a totally different rhythm of life. Now, when you put them side by side like this, it really hits you. You have our familiar 365-day cycle right next to their massive 480-day one. That means an Arreqqana year is well over 100 days longer than ours. That's a huge difference. And honestly, it's the key to this whole thing. So if you do the math, just divide 480 by 365, you get this magic number. This is our conversion factor. For every single year that passes for them, about 1.3 years pass for us. This little number is going to be absolutely essential, so let's hang on to it. Okay, so we've got our tool, we have the key. Now it's time to actually use this conversion factor to turn that huge number, 11,520 AQ, from some abstract alien count into a real, concrete span of time and years that we can actually wrap our heads around. And the math here is actually super straightforward. We just take our starting date, that 11,520 AQ, and we multiply it by that magic number we just found, 1.315. And that'll give us the total length of time in good old-fashioned Earth years. Wow. And there's our number, over 15,000 Earth years. That is an enormous stretch of time. I mean, that's basically from the end of the last ice age all the way to today. But here's the catch. This number is just a duration. It's a length of time, not a specific date. So the big question is, when did this 15,000-year clock actually start ticking?
Right. So we have this huge chunk of time, but it's just kind of floating there, totally untethered. For it to mean anything, we need to anchor it to our own history. We have to find year zero for the Arreqqana.
And here it is. This is the final, critical piece of the puzzle. Their own records say that year zero AQ lines up with roughly 9,000 BCE on our timeline. This is our anchor. This is the moment their civilization's calendar officially kicks off.
Just to put that into perspective for a second, 9,000 BCE is about 11,000 years ago for us. This is the Neolithic period. We're talking about the very dawn of agriculture, the first settled human villages. Their entire recorded history starts deep, deep in our own prehistory.
Okay, this is it. We have everything we need. We've got the total time span in Earth years, about 15,000, and we have the starting point, 9,000 BCE. Now we can finally put these two pieces together and solve the mystery of 1152 AQ.
So let's do this. Picture our timeline. We're going to plant a flag way back at 9,000 BCE, and then we're going to jump forward in time by that massive 15,153-year span. So, where do we land?
Whoa, okay. The year, 6000 CE. So this date, 115020 AQ, it's not in our distant past at all. It's in our distant future. That completely flips our understanding of what this number means.
And this table just lays it all out so clearly. You can see their founding, way back in our Stone Age. Then their next big milestone, an expansion into kingdoms, lands around 2450 CE, which is still a few centuries in our future. And then you get to their present day, which lands us squarely in our year 6000.
So let's just be super clear about this. Their present day is about 4,000 years ahead of ours. They are literally living in what would be our distant future.
And that just leaves you with this one absolutely mind-blowing question, right? Think about everything humanity has accomplished in the last 4,000 years. We went from building the pyramids to landing rovers on Mars. So what could a civilization possibly achieve with another 4,000-year head start? what would that future even look like? It's an incredible thought to end on.